All right, to start, I've got a little practice test to give you, and I want you to try this hour. It's going to take probably 25 minutes or so of class, and we'll take some time to grade it. But before all of that, I want you to just type in this data right here. We'll use that for question 9 of the practice test, but type that data into your calculator. I'm going to tell you a little story. Those dollars, let's say that those are in millions. Can you imagine if you worked for a person, you worked for this as a maid for a old lady, and she got to know you and like you, and as she was getting older, she was realizing, well, I've got like $23 million. I might just leave $1 million to my maid. Let's say she decided to leave these amounts based on, if you were working for her for 1 year, she left you $1.8 million. If you were working for her for 2 years, that's like way more than just double, because she got to know you really well. So she gave you 4.7 million, which kind of shows you the data is kind of quadratic. 3 should be 9 if it was truly quadratic, but if you were there 3 years, she gave you 9.2 million. So she's just a crazy old rich lady, and she can do whatever she wants with her money. So there's your data. Please put it into your calculator under Stat, Edit. Okay, and then it's a quadratic regression problem. So go ahead and see if you can get the quadratic regression equation. And I just want to talk about this in the context of a news story that just came up today. So there's a 92-year-old lady. Everybody in her family had died. She was so old, you know, she kind of outlasted everybody, including her kids. But one niece was left. And the niece and she didn't get along terribly well. And the niece's idea for her grandma was that she should probably go in a home because it was hard for her to get around, and she didn't live right nearby, and so it was tough, you know, to help her. So she was like, it'd probably be just easiest if grandma went in a home. She kept on trying to convince grandma to go into a home. Her grandma lived in a house on the ocean in Australia. It's a true story, by the way. And grandma didn't want to go into a home. She lived in this beautiful house overlooking the ocean. You wouldn't want to go into a nursing home either. Rather, she lived there her whole life. My dad was the same way. He'd lived in his house his whole life. Didn't want to have to go into a nursing home. He kept saying that over and over again. I just want to be able to stay here. And so we were able to make it work. We had people come out to his house and help him there. And he was able to die in his own bed in his home. That's what he wanted. Didn't want to have to go somewhere else. He lived there his whole life. Raised his kids there. So anyway, this lady, when she died, she didn't leave any money to that niece. She left it to the next door neighbor who had helped her stay in her house. The next door neighbors had come over, helped her with their finances, like keeping her checkbook straight, and had helped her like move her stuff to lower levels where she could access it, and just kind of took out her recycling for her. And so you could paint two cases. You could say they were evil people who were trying to steal the inheritance money, or they were just being nice to the old lady who lived next door. And so I don't really know. I don't know them. I don't know exactly what happened, but I do believe it's the right of the old lady to leave her money to whoever she wants. So she left $13.2 million to her next door neighbor and nothing to her niece. If there's any moral to the story, if your dad or if your grandma says, I don't want to go into the home, listen to them. They might be able to make it work staying in their house. It might be harder. Might have to hire people to come in and help keep them, safe or whatever. But listen to them. It's their choice. I'd feel a little bit like I'd lost out if I was the niece who didn't inherit $13.2 million. And I'm not saying she did it right. In my ideal world, maybe you'd leave your niece something because she was your niece, but you could also be nice to the next door neighbor who was nice to you. So, it is interesting around inheritance time. It can be challenging for people because they start, wondering, is people being nice to me because they want my money? Or probably hard for those people that just won $500 million too. Or actually happened like $250 million, because now they're all of a sudden going to have their friends that are going to be like, so you won $250 million bucks. All of a sudden they're being really nice to them. It happens to everybody that wins the lottery. Apparently, it's like expected. Your family's going to come after you, and it'd be great if you could lend me some money. Anyway, it's apparently really tough. Yes. Yeah, there was some study that said 70% of lottery winners have no money, but within, like, I can't remember how many years it was. They're down to not only zero, they're actually bankrupt, meaning that they have more liabilities than they have assets. Because I think they think unlimited money, and it's really not. Even 250 million, it's not unlimited. You can spend it pretty quick if you try. It might take you a while, but all of a sudden you buy 3, 4, 5 houses. That eats up a lot of it, and then those cost a lot to maintain. You got taxes, you got fixing, you got one guy that I was reading a story about the lottery had won 250 million on Christmas Day 10 years ago. And he said, here was the net result. My granddaughter overdosed on drugs, and I can directly track that to the money because she got the money because I gave money to my daughter, and my daughter had too much money, and all of a sudden she was the spoiled rich kid and had tons of money to get drugs. And so, yep, my granddaughter's dead because of this. I got divorced because of it. All my friends, I couldn't tell if they were friends or not because whether or not they were trying to get my money. So I didn't know if I had any true friends anymore. And so he doesn't recommend winning the lottery. And screwed his life up. So don't wish that you were the one who just won 250 million. Try to be happy with whatever you have and wherever you are. All right, hopefully you entered this into your calculator and then you got something like this on the y equals screen. I'll go through it just in case you had trouble. I'm going to go to stat, calculate, quad reg, because this was quadratic kind of data. And then I go L1, which is right above the 1. So second L1, comma, second L2, comma, and then I got to put in the Y1. If you have the new operating system, it's going to give you separate lines to put these on. And the one you'd put the Y1 is on store. You'd look for that to put the Y bars. So I go, here is my Y. And there it is, and I hit enter. And it puts that equation on my screen, which I could write down and get the credit for having the equation. And it also puts it in here on the Y equals screen. And then if I go to my table, I bet some of you had trouble finding 7.3 on the table. If you haven't already looked, your table's probably not numbered by decimals like mine is, unless you have gone to table settings, which is right here above window. It's table settings. Nope, I hit window by accident. Sorry. Above the window is table settings. And have your table count by 0.1s if you want it to count by 0.1s. That's where it would go right there. Hit enter. Now my table's counting by 0.1s, or it was. There we go. And so 7.3 years, she'd have left you 46 million bucks because she was quadratic like that. Quadratically generous like that. Okay, any questions on how that works? I'm willing to do more quadratic regressions, but they're so much like linear regressions that I'm thinking that you're going to be okay on. Raise your hand if you feel comfortable on that kind of problem. Okay, thank you. All right, so now let's look at the rest of them. I'm going to just simply change this last problem a smidge so that you can still use the same data. And instead of saying, how many dollars will Tim have at time 7.3, I'm going to change it to Tim inherited, or yeah, Tim got inherited, I'll say inherited. 1.3 million. How long was he working for her? Okay, so that just changes the problem a little bit. You got to figure out what I gave you. Look it up in the table, and you'll have question number 9 done. All right, questions 1 through 9 are a good representation of what we've been learning lately. Give them a shot. It's going to take you a little while. And we're exchanging and grading. So write your answers legibly so people can read them. And if you have trouble with it, I'm going to talk over every one of these and how to do it. But I want to know what you know right now. Yes, sir. Clarifying question? Okay, then I'm going to pause this. Okay, now that we're done with the quiz, we are going to take some time to see how to do them. The first one, it comes to our first equation that we need to have memorized, which is y minus y sub 1 equals m times x minus x sub 1. All right, now you can find the slope, the m, any way you want to. Okay, I'm going to show you this way because it also works for the quadratic one. You put both these points into the equation. Okay, I'm going to choose to call these my x and my y, and this my x1 and my y1. It actually wouldn't matter if you reverse them. Doesn't matter. Okay, so I'm going to say x is 1, so I'll put a 1 here. Plane y is 6. X1 is -3, and y1 is 12. I just want to show you that this works. 6 minus 12, -6, equals m times 1 minus -3 means 1 plus 3, which would be 4. And so final answer is m would be -6/4. Yes, you can reduce that, but you didn't have to. There's my slope, but I'm not done because I now have the slope, but I have to use this big equation again. Y minus y sub 1 equals m times x minus x sub 1, and put that -6/4 right here. And now I put in either point I want. I would choose this one because they are both positives. So x is 1. Oh, not the x. Sorry, the x1 is what I want to replace here. The x1 is 1, and the y1 is going to be 6. Now, did they have to use the 1 and the 6? No. They could have used this being 12 and this being -3. That'd have been okay too. And I'm going to stick with one. Right answer is right there. The other right answer would be replace that and that with a 12 and a 3. Any questions? Okay. Now, should this really be 3/2? Yes. But I didn't want to make a big deal if the kid forgot to reduce, because the rest of the problem is so much more difficult than the reducing part. Okay, moving on. If it's a parabola, you have to have a different equation memorized. Y equals A times. This is why I wanted you to have paper out so you could take notes if you needed to. So some kids I know didn't know this formula. X minus h squared plus k. If you don't know this formula, you're not going to be doing this one right. All right. So now I'm going to figure out what A is by sticking in both this point and that point. So I'm going to choose this to be x and y and this to be x1 and y1. So my x is 3. Oh, wait a minute. I don't really have... I have a vertex. That's different than an x and a y. What's the vertex? H and k. Okay. So the vertex is 3 goes here, 5 goes here. And then my x1 and y are, my x is 1, my y is 15. Now I'm going to rewrite it. 15 equals a times 1 minus 3 squared plus 5. That part's -2. -2 squared would be 4. 15 equals a times 4 plus 5. It would have been really big mistake to say 4 plus 5 and make this 9. I can't do that because this 4 is being multiplied here. It's stuck to the a. So I have to now subtract 5 from both sides, and I'll have 10 equals 4a. A must be 10/4. Again, it'd be tempting to just think I'm done. I've got my answer. You've got the hard part of the answer. Now you go y equals a, except I don't put a. I put 10/4, or what's better than 10/4? 5/2. And then x minus h. What's the h? There. Squared, don't forget that, plus k, which is 5. And there's your final answer. If kids forget the squared, mark it wrong, because that's what's going to happen tomorrow. Kids forget the y equals or the f of x equals, mark it wrong, because that's what's going to happen tomorrow. There's no half credits, you know. Okay. Very easy mistakes to make. If they forgot to reduce 10/4 to 5/2, I probably wouldn't have marked the whole problem wrong just for that. So. Anything you want to ask about? Like, I don't get how you did this part. Or seeing no questions, I'm moving on. What is the vertex in this? Well, that just tests if I know how to do those. And I don't say -3, -9. I say 3, -9. Why did I switch that one? Anything on the inside is counterintuitive. It's the opposite of what you do. There's my vertex. And the next question is number 4 is going to ask you what's the axis of symmetry then. That right there, x equals 3. You have to say x equals. They just said 3, mark it wrong. You have to have the x equals. Never just leave a number answer like 3. Say x equals 3 or y equals 3 or 3 comma 0 or something. Just have a number. All right, so that's number 4 is x equals 3. Because it was the beginning of the vertex. Any vertex they give you, you say it was 5 comma 12. You just take that. It would be x equals 5. Okay. Next kind. Vertex form. Wait a minute. Vertex form. That means I need to have the vertex. What gives me the vertex? Complete the square. Complete the square. How do I complete the square on that? First, you multiply it out. A lot of kids will have this part right. X squared, outside, inside, makes plus x. And the last is minus 12. A lot of kids, though, don't know what to do after that. What you're supposed to do, if you want the vertex, complete the square. Okay, so am I going to factor out? Or no, I don't have to factor anything out. I can just leave it as x squared plus x. Now I need a plus a line and a minus line and a minus 12. Bump that negative 12 over. This and this makes my perfect part. Half of x. Ooh, that's weird. How do we do half of that? It's half of 1, right? So what's half of 1? It's a half. Squared. Half and squared. And if I take 1/2 and I square it, I get 1/4. And then I'm going to go to the next level, which is this part is the perfect part. X plus a half and x plus a half. And then this is minus 12/4. Or 12 and 1/4, sorry. Now, could I put that together into one big fraction? Sure. Could I say it 12.25? That'd be fine, too. And then that's y equals x plus a half squared, because this and this are the same. That's why I could say it's squared. Minus 12 and 1/4. That's a good answer. But what did they ask me for? Vertex form? Is it in vertex form? Yes, I'm done. Sometimes they'll ask me for something like the vertex, and if I stop here, I'd be tragically flawed because I haven't said the vertex. But this is vertex form of the equation. Any questions? Can I give them half credit for this or whatever? Yes? Yes, they can have half. Just show them which part's right and which part's wrong. All right, next one. Complete the square. At least it says what to do on this one. So you go x squared plus 4x plus a line minus 7. Completing the square now. I take the little German boy's advice and take half of 4 is 2. 2 squared is 4. 4. And then I say x plus 2 quantity squared. And then these guys together make minus 11. And if I forgot that, oh, so painful. There would be the equation that's in vertex form now after I've completed the square. They didn't ask me for the vertex. If they did, I would have said negative 2 comma negative 11. They didn't ask me for the axis of symmetry, but if they did, I'd say x equals negative 2. Yes, sir. Yep. If there's no y equals, it is wrong. It's not going to hurt them much right this second, and it'll save them major pain tomorrow. If they get spanked now, they might not make the mistake tomorrow. All right. Complete the square for this equation. All right, I got a 3 to factor out. Do you get that I have to get this 3 off of the squared, otherwise it won't work? I can't have that there. So I get the 3 out, and I'll have x squared plus 4x. Notice I do not factor it out of... Wait a minute. I have a 12 where I should have a 2, sorry. I don't want to factor it out of this. I just factored out of the first 2. And then bump the negative 2 way over to the end. Plus a line, minus a line. Then, what's half and square? Half of 4 is 2. 2 squared is 4, and 4. And now the most common mistake. The 3 has to go here. Because this 3 will be multiplying that line by 4. I need a 3 to multiply that line by 4. It's really easy to forget that. So now this is the part that's perfect. X plus 2 and x plus 2. And then this will make negative 12, and negative 2 makes negative 14. Put it all together, I need a y equals 3 parentheses x plus 2 squared minus 14. That's completing the square. I'm going to look back at the original question. Complete the square. Good, I'm done. If they asked vertex, I'd have to pull it out of there and say -2, -14. But they did not ask me for that, so I don't really need to do that. But here's the x equals -2. What did I just write there? What's that called? Axis of symmetry. That's right. Okay, moving on. Name the axis of symmetry. Ooh, then it'd be nice to have the vertex. How do I get the vertex? Complete the square. It's back to that again. If you know completing the square, you're going to know a lot of answers tomorrow. X squared plus 3x plus a line minus 1 gets bumped to the end. This is my perfect part. Now I can do half and square. Half of 3 is 3/2. And squared. 3/2 squared is going to be 9/4. Now the part everybody forgets, including me, that 2 is to go there. Y equals 2, parentheses, x plus 3/2. Now, I could write it twice, or I could just say squared. And then this part, -18/4 minus 1. Would you approve if I, instead of have a 1, I say 4/4? Now it's got a common denominator. And now I can put them together. Y equals 2, parentheses, x plus 3/2 squared. Those guys together, -22/4 would be a good way to say it. And what did they want? They want the axis of symmetry. See how easy it would be to stop and go, oh, I'm done now. But I haven't actually got the answer yet. The answer is the axis of symmetry, which is the first part, which is that part. And so it's x equals -3/2. Not positive, negative. Because remember, it's always the opposite of what's in there. There it is. Just give them a half in this case. Yes. -b/2a thing? Yes, absolutely. It would still be -3/2, but that -b/2a actually would have been smarter in this case, but it's not. You don't have to do it that way. Complete square does everything. Yes. They didn't have the last part? It's wrong. They didn't answer the question at all then. Yes. So this part is actually irrelevant to my answer. All I need is this. If they have this, they're good. Yes. How about the what? Louder? Okay, did they do a mistake on this part of it? Then they're okay. All right, because all we needed was the axis symmetry part. And the last one, if we have 7.3 for our... Oh, wait, we changed this problem, right? What do we say it was supposed to be? $1.3 million is given to us. Then how much must he have worked? It comes out to like 0.7, I don't know, 0.72, 0.73, something like that, years. And you look that up on the table. Okay, so you'd go into your table here. You'd find where 1.3 million would be. So I'm just going to keep going up until I hit 1.3 million. All right, I'm going to go to my table settings and reset it to be like start the table at 0, hit table, and now 1.3 million would come up right about there between 0.7 and 0.8. So any answer between 0.7 and 0.8 was fine there. Okay, score out of 9. Back to the owner. Who had a 9 out of 9? That would be very impressive. Wow. Okay. How about 8s or 8.5s? 7s or 7.5s? 6s or 6.5s? All right. If you're worse than 6 or 6.5, you got some studying to do. Unless you know your one dumb mistake you made over and over again or whatever. Okay. So, I hope you feel smarter than when you walked in, and you have some studying to do. The worksheet I gave you yesterday, finish it and check it, and that's when you start studying. When you finish your worksheet and you know you did them all right, or if you have a couple wrong, that's your moment to start studying. All right.